Start at A, I'm going to go to B, I'm going to go to C, and go to D in our calibration procedure. Welcome back to Get Tales. I'm going to continue with a design discussion now. And as a favor to y'all, I have redrawn the calibration mechanism, which is hiding somewhere in there. Here we go. So, where do we start with this? We're going to start here. Touch a floating action button, move some values, press the check mark, adjust some values, press the check mark, and verify. Here's our steps. We're written out a representation of where the motor will be, not a drawing on the screen, but where the motor commands will put the things to it. So here we have the main screen, the gallery screen. Better put. So in the gallery screen, we have the kind of throwaway area, the app name. No buttons at bottom, except for that. A floating action button with an icon yet to be decided. The floating action button, when calibration is needed, will show an icon that should indicate calibration is needed. Maybe an exclamation point. I haven't really given it much thought. The icon, when it is calibrated, should be the traditional plus sign for adding new objects. But we're only going to talk about the calibration procedure here. Both will go to a very similar screen to the one that we've already seen in the demo and also roughed out in our design here. This screen. Start at A, I'm going to go to B, I'm going to go to C, and go to D in our calibration procedure. Step one is that the arm of the machine moves the writer as close to the machine as possible. That is point A. It could, depending on the machine, that A may be closer depending on where it's rotated, but let's just assume that it's a constant stop for now. It comes full to the stop, backs off perhaps a hair, and then asks the user to place a ruler zeroed at point A, and placing that ruler parallel to the arm. In this configuration, the machine, as I see it, would look from the top like this, from the side, something like this. And the arm goes out. And we are full on stopped this way and then backed off a little bit. This tells us where the nearest point to the stop we can get to is, A. But that just gives us position. We need distance for 2 motors. So the ruler's placed 0 at A, and we ask the user to move the machine forward by using one of the buttons we have, and move this arm out till we get to whatever this calibration length is. I would intend it to be a user supplied number, because the user could choose to have a different length of arm. Could take this arm off and drop in something that's 3 feet long, say. This moves from A then to B. It says, so once the user's placed the ruler out to B, and they've moved the motor out, then press the check mark once this has been targeted. Then the user just roughly turns the ruler like so around B, keeping that 11-inch marker, say, at 11, at B. Then the next button they'll be pressing will slowly increment the rotary motor from B to wherever C is. And C will be one place where the curve of this arm spinning around here will meet that same number, say 11 inches. Then we're at C. Now the app has the calibration it needs for both the rotary and the radial motor. What it then does is it returns the radial motor all the way back to D. I say back because it will look like this again, but just turned. And it should move to D, which is the same distance from B to A, same number of steps. And it should then be able to calculate the distance between D and A and give that as a number to the user. The app should display that distance as a checksum. So the app says, oh, well, I've gotten, this is, let's say, 3 inches. It's hard to tell with the not knowing what this footprint is, what that number would be, but let's say it's 3 inches. The user can then measure a distance from D to, if they had left a mark at it, A, and be able to verify that the data is inside the app correctly. Now, you could just say, oh, we'll make the app always have the data. However, I have known myself, and I've seen other users, do not trust the application logic that they're presented with at first. People like to see that the thing actually works. This is just like doing a unit analysis at the end of an equation. You want to see that it worked. You clearly the UI shows that it worked, but double check, right? That'll allow that user to do this. It also returns the motor back to its resting position, I would guess. That's the calibration. Now, I think that covers it. I, of course, welcome anyone who would like to inform me about geometry errors I've done here. See, it would drive out like that, come over like this, back in like that. The benefits of this is that it uses a simple tool that other people will have. It reuses a simple tool that we are already using for another screen, a software tool, and it also is able to notify the user when action is needed by the change of this floating action button. Well, I think that's all for today. Happy hacking.